So today's talk, I'm going to basically it's to make it sort of brief at the same time, give you insight into how we use data in Flipkart, data and technology in Flipkart. I thought what I would do rather than talk about a lot of different things, focus on one area, which is assortment design, which is or selection design, which is one of the key pieces of e-commerce. So I'll give you a little bit of an intro, the first 5-6 minutes on Flipkart and Flipkart data and technology pieces, and then get into the use cases. Yeah, so just see, I always start out with the slide, and the reason I start out with the slide is it's important to understand that anything you do at this scale, right? We have around 450, I think it's closer to 500 million registered users, around 150 million products. We get around 2.5 billion monthly visits. And around deliver to pretty much all the pin codes, very large fraction of the pin codes in India. And we have around 80 plus product categories. And the reason to show this is because anything you do has to be done with scale, and it has to be done through machine intelligence and can't be done through just human sort of, it can't be done manually, basically. It has to be done through machine and machine intelligence. So I think just to give you some view on what the data teams in Flipkart do, I would break it into three pieces. Okay, first is what I call measurement science. I think this is one of our, if I look at it, a biggest differentiator or one of the most, I feel, best pieces of the organization we have built is around measurement science, which is the ability to leverage statistics and machine learning to build a very hierarchical structure around just things like targets and so on. For example, at a company, like connecting the strategy to execution through data is what we call measurement science, which is, for example, let us say one of the objectives of the business is NPS, Net Promoter Score. So the question is to build a set of hierarchical ML models. What drives NPS? Maybe a bunch of things: delivery experience, product quality, seller experience, so on and so forth drives NPS. And then what drives those, so on and so forth, to build a hierarchical set of ML models that help people get targets at the most granular level in the company to be able to drive decisions and to drive sort of their targets so that everything adds up to a larger goals of the company. So that's the measurement science. The second piece is data-assisted human decisions. This is your classic, what you would call business analytics and so on and so forth, where what categories do you invest in, how do you drive growth, how do you growth hacking, operational and planning initiatives, what do you sort of, what areas do you develop your seller ecosystem, things like that, classic business strategy, operational strategy, logistic strategy, and so on. And the last one is the classic AI, right, which is data-assisted machine decisions. This starts from things like discovery, search, recommendations, personalization, listing quality, selection, trust and safety, so on and so forth. Yeah. So I'm going to focus on so then one other thing I wanted to talk about was how do we operate? For us, experimentation is very core to what we do. Everything, we run around 80 to 90 feature launches every week, and each one of these go through a pretty robust A/B, and it's a very complex problem by itself, the A/B culture itself, because the point is if you're running 80 or 90 A/Bs at the same time, how do you separate out the outcomes and so on and so forth, so you have universal holdouts. And some cases you can't run an A/B. For example, you can't run an A/B on, what prices sellers put on their product, because you can't price discriminate. So in those sort of situations, how do you build synthetic controls, right? So understanding how to build synthetic controls where you can't run an A/B, long-term experiments to assess impact, real-time analytics, dashboards, so on and so forth. And then we have around 200 plus ML models that are running in production in our platform at any point of time. So what is customer experience? Broadly, it's very simple. In e-commerce, there are 4 stages. One is pre-order, your ability to browse through the app, look at the product, so on and so forth. Then the second piece is, do you have the right selection or assortment? That the consumers want. Are they at the right price point? Are they right quality? All of those things. Then the next piece is the post-order experience, and the last one is product quality, right? This is essentially what customer experience in e-commerce means. And if you are in e-commerce, this is what you should be working on. Whether you are in analytics, data science, business, operations, whatever it is, you should be working on one of these things or multiple of these things. And today I'm going to focus on selection design. So what I'm going to do is take you through, see, the reason I wanted to focus on one use case was you can actually go through multiple scenarios where data science, ML, analytics, all of these are used in one problem statement and at scale. So that's the whole endeavor here. Yeah? So what's selection or assortment design? The first thing, what is the problem statement? The problem statement is what is the width, depth, and quality of assortment we need, right? What does that mean? Selection width is how many product lines. For example, Flipkart is a horizontal platform. A horizontal platform means our goal is to provide products and all areas of retail. We have fashion, you have mobiles, you have electronics, you have auto accessories, you have general merchandise, pretty much everything. You have beauty, healthcare, all of these things, right? So that's width, right? Is the number of product lines. And depth is the variety within each product line, right? So, for example, let us say you have sort of a Nike shoe, right? Within a Nike basketball shoe in the 2,000 to 4,000 price range, how much selection should you carry so that the consumers feel like they have enough choice? If you carry just one style, obviously they don't have enough choice. But beyond a certain point, whether you carry 50 styles or 2,000 styles, it may not make a difference to the consumer. So what is the right depth? And the third piece is selection quality. Are you bringing in the right designs? And this is where you'll see some, I'll try to quickly get to that because that's where some of our more recent technology endeavors have been and been quite successful. So selection width, if you take selection width, I'll quickly go through this. Selection, you look at width. When you look at width, you look at selection, which is head, tail, and head, torso, and tail selection as a distribution. Head selection is the 5 or 6% of products that account for 50% of sales. Torso is probably 15% of products that account for 20% of 30% of sales or something like that. And the last tail is 80% of selection that accounts for 80% of sales. You get the picture. I don't know whether all of these add up to 100, but you get the idea of what I'm trying to say. Yeah. So the whole thing about width is making sure that the tail and torso are well populated selection. So this is sort of how we think about it, right? Basically, you get a bunch of search queries, 20, 25 million search queries every week. These are unique, different search queries every week. And we use natural language processing to categorize and cluster these queries into a bunch of different clusters. And then you identify poor performing clusters. Typically, you look at, when you say it's a poor performing cluster, you look at a metric called click-through rate. Click-through rate is when you're trying to search for something. Do you actually find a product and you click on one of the impressions and go to look at the product? If that is happening below a certain threshold, that means consumer is not finding selection in that area. So those are areas where you need to add selection. So from there, you use those sort of poor CTR clusters or clusters where it's much below the average of the platform. And using those, identify sort of based on these clusters where selection is lacking, identify seller affinity in the sense that we have seller affinity models which identify sellers who could potentially fill that selection, and this gets pushed as an insight for the seller to start adding selection in that area. So this is a scalable way of everything. What you will see here is what is a scalable way of adding selection. Yeah, this is for width. Now let's talk about depth. like I said, what is depth? Depth is essentially saying that, do I have enough? How do you go back here? Okay, got it. Yeah, so depth essentially is saying that, do I have enough styles in a given, for a given product? Yeah. For example, so just a few definitions for you to understand what is depth. The most important definition is a market SKU. What this means is, this is the lowest unit of demand from a consumer perspective. For example, it could be something like a Nike basketball shoe in the 2,000 to 2,500 price range. Okay, this is how a consumer thinks about what they are trying to buy. Okay, this is a market SKU. And how do you again build these market SKUs? Again, you look at data, the browse data and the purchase data. You look at co-browse, co-purchase data at scale, and then you are able to identify from a consumer perspective which are products which to them seem like a single unit of demand. Yeah, so that's how MSKU is determined, market SKU. And each market SKU, the depth means for each market SKU, how many styles or how much selection do I hold? And that is essentially what we are trying to do here. And basically, what we are trying to determine is how much depth is required. Do I need 50 styles of my given SKU, or do I need 20 styles, or do I need 100 styles? And for this, the way we look at solve this problem is, first we try to predict demand. And demand obviously is a function of a whole bunch of different things. I won't get into that. First, you predict demand, where one of the attributes or features of demand prediction are number of styles. Then what you do is, once you build a good model to predict demand. Once you predict demand, now you look at the partial dependence, which is essentially what is the impact of that one attribute, which is selection depth, on demand. And so usually it ends up being a S-shaped curve, which means that if you have selection, in this particular case, it's a brown loafers. In this particular case, what you see is, if you have selections above 11 or 12 styles, then demand doesn't pick up at all. But above 15 styles, it remains pretty much flat. So at the least, you need to have some 13, 14 styles of this particular SKU to have a demand that consumers feel is enough. So that is the whole model on selection depth. The last piece, this is where I wanted to spend a little bit more time, which is on the selection quality. And this is where some of the key buzzwords on generative AI and something, these are some very good applications of generative AI, right? So the first problem is identify products. So you can think of as two problem statements. First problem statement is, see, in Flipkart, you have a lot of selection. Which are the selection that you should explore? All of these selections don't get shown. You have 150 million products, which means that only a small fraction of products are shown. Which of those products should be explored, which we believe have higher potential with the consumer? That is the first problem statement. Second problem, the first problem statement is where you already have assortment or selection. Second problem statement is, how do you design selection? See, we have 450 million registered users, right? With that kind of a population, you understand their browse behavior, their purchase behavior, gives a window into pretty much how India buys for any category, right? And so now the question is, how can you use this data to design products? And here, what we want to do is give insights to sellers, very, very clear-cut designs. Go design this and bring it to the platform, it will sell. That is the second piece problem. So both are related. The first one is a more classic machine learning, and the second one is more generative AI. So let's talk about the first piece, okay? What is the problem here? The problem here is, if you look at it, we have, let me go there, yeah? We have 150 million products, okay? And only 25% of our selection gets discovered because of the scale of the platform, and only 10% of that 25% actually gets sold. And this is true of any horizontal e-commerce platform, right? And discovery and search are based on past performance. So your classic discovery and search algorithm is an exploit model, which means what is selling well, you will show more of it, sell more of it, and so on and so forth. But in a category like fashion, there is a lot of churn of selection. There is also a lot of freshness, fashion changes, styles change, things like that. So for you to remain relevant, you should also explore. You should start figuring out what other products to expose to the consumer so that they will buy. Now, typically when you explore, what you see in the left is often what happens. Some of them don't pick up at all, which means you are wasting very valuable real estate space on the app where you're showing things that are not going to sell at all. So it will be good to have some idea of what will sell upfront before you start exploring so that the exploration is more intelligent. That is the problem statement, yeah? Framework for identifying high potential listings and bringing them into the exploration funnel, and shortlist potential listings that can be sort of consumed by our sellers. And sellers can bring those more of those styles. Understand what sells. So here, basically, the problem is it's a model to build, basically, predict what is a high potential listing so that you can use those listings for exploration. Yeah. So here, basically, what we look at input signals are features of the product images, so on and so forth, product attributes, image attributes, and so on. And we are trying to predict that we have created a target variable which is in some way correlated to potential conversion. Yeah? And so based on that, we build a model and then predict, we call it a hypo score, high potential score. And if you look at it, predicted hypo scores correlates very well with conversion. And what we do is we take a threshold. That threshold could be depending on a vertical or a category, 70%, 80 percentile, 75 percentile, so on. And we preferentially drive exploration to those categories, right? Now, this is for selection that already is in the platform. But what selection should we bring to the platform is the second problem to solve. And here is where generative AI has really transformed this for us in a very big way. So basically, you're familiar with generative AI, ChatGPT, text generation, or audio synthesis. There are products on image synthesis, which is what I'm going to talk about, DALL-E and Stable Diffusion. There are video synthesis products and 3D mesh synthesis. So generative AI, literally in the last 1 year, has really transformed the space. Yeah. So if you look at it, so we leverage something called a Stable Diffusion model to actually design new fashion in certain areas, particularly in the unbranded women's fashion area. Yeah. So there the problems are twofold. The first problem is first understanding what selection gaps exist in our platform. So what are the attribute combinations or feature combinations that don't actually exist in our platform? Yeah, that is the problem number one. So you can go there, look at the picture there, catalog, you look at a bunch of things, the blue checkered, there is 0 products. That's just an example. Okay, you see the red line in the bottom, that's a selection gap. So these are attributes where selection gap exists. Then you send it through a Gen AI framework, Stable Diffusion framework, and then you come out with a design like this, let's say. Now, the second piece is, will this design sell or not sell? That is the second piece. Now you go back to your hypo model, which I just talked about, and you create a design through generative AI. Now you try to predict whether this is a high potential selection or not. If it is a high potential selection, then you send that design to the seller and they will design it and put it on the platform. So that's the cycle of how things will work, right? And just to go into Stable Diffusion, it's a sort of generative AI process where you you give some input, both textual and image data, and in the forward process, you add some Gaussian noise, and then the reverse process, the machine learns, and comes up with novel designs within the constraints of the framework you have given. And it could be the features that are relevant for the selection gaps that exist. Yeah? And so these are some of the designs that have been generated by our AI. And so basically what you see here is essentially there is a Z-score or a hypo score. So you generate these designs and then it predicts a price point. If you go back to this, it predicts a price point and potential to sell, right? And both are obviously related to each other. Each design is high potential at a certain price point. And it gives that, and then based on this, we take a cutoff and send some of these designs to our sellers. And and these are some actual designs that have been designed through this process, and actually you can buy them on Flipkart right now, basically. So this is the broader process that we follow in driving using generative AI to drive fashion design. This has become, as you guys are well aware, a very, very hot area. And in the last 10, 12 months, this has become much easier to do than it was before. We had tried this in the past with far less success, but with things like DALL-E, Stable Diffusion, and so on and so forth, this is sort of thing.